Coming. Martijn, one of the organizers of this conference, hates cats. He's done many presentations about how you shouldn't have kittens in the talk to either spite him or maybe given a little, there will only be 2 kittens. This is one of them. I'm happy to take any questions. Just raise your hands if you have any questions about your specific setup or something that goes pretty in depth. Let's just catch up after the talk. I'll be outside, breaks and so on. So a little bit about me. That's what I like to talk about. I used to work for a company called RIPE NCC. It's where you go here in Europe to get IP addresses. I used to run the RIPE database there. After that, I went to a company called Canonical. For those of you that run Linux in the cloud, you've probably heard of Ubuntu. Apologies for the state of Java in Ubuntu. We didn't do that well there. And afterwards, I went to a company called Krux, where I run operations. And Krux is a company that does basically Google Analytics for audience rather than for traffic. Or if you want to think about it this way, that thing that Netflix does to figure out what you want to watch, and that thing that Amazon does to figure out what you want to buy, we do that for any type of user content. And we do that for the websites we're on. So we also do this with a very strong focus on data privacy. And we're not an advertising company. We do this for web pages like the New York Times, the Wall Street Journal, and so on. And we handle, on their part, the analytics and recommendation. We don't share that data. It doesn't go anywhere else without their consent. So to give you an idea of who we do this for. For every request that these companies get, we get 1 or more as well. And some of these are top 50 websites. So in the end, that means we get a lot of traffic. And we get it from all over the world. Now, the traffic itself is one thing. We're also on the critical path for that website delivery. So when you go to the New York Times, one of the first calls they'll do is to us. We send back some data to help personalize the page. The rest renders. So when you are down, when you're on the critical path for the New York Times, that's a really bad thing. So to put some colors to the requests that we get, Twitter is at about 7,000 a second on average. I think their peak was at around 15,000 when the winning goal was scored during the World Cup. Wikipedia is about 8,000 articles a second being read. We get about 10,000 new data points a second, just to add some color. Now, to be fair, Twitter does way more with their incoming tweets in real time than we do, but just to add some color. And in terms of reach, we reach about 600 million users worldwide. It's not quite YouTube, but we do pretty okay. From these users, we get about 500 gigabytes of raw data per day. We get that in at a rate of about 65,000 requests a second. And it results in a key store of about 750 million keys. And we had to deploy that somewhere. And we chose the cloud. Cloud is specifically good if you are a startup that is growing fast. It is fantastic in the sense that it's really low CapEx, but it's high OpEx. So if you're not sure your plan's going to work yet, it's a great place to start. It's fast. It's flexible. You get a pretty controllable price point without no upfront investment. And this is why a lot of venture capitalists will really urge you to start your company in the cloud. And many of them have lots of components you can build off. But there are obviously really downsides as well. The failure modes are completely different. The thing that worked in the data center may not work anymore in the cloud. You don't control the network. You don't have a dedicated 10 gig Ethernet cable to that box you really need to reach. You can't add another power supply. There are no diesel generators, memory-backed RAM. Things can fail outside of your control. And they'll fail a lot, and you're going to have to deal with it. So for the talk itself, I'll focus on AWS. Excuse me. I think it's the leader in the infrastructure as a service space. It's also the most fully featured, and we targeted it at Ubuntu. And I work on it at Krux, so I'm also best equipped to speak to it. This is always a slide that makes me a little bit sad. This is the first black day for Amazon. Who was in AWS on that day? Okay, I hear you. How well did you sleep that night? You didn't sleep at all. It was the first big EC2 outage. I think overall it took about 28 hours for everything to come back. And a lot of companies were affected. And because it was their first big outage, it was the first time that a lot of these companies were exposed to this type of failure. And the follow-up question was like, well, if it can fail like that without us being in control, we can't add the diesel generators, we can't do any backups, should we really be in EC2? Should we be in the cloud? Can we really trust somebody else to do this for us? So what happened? Somebody made a network change. That was it. But it was a cascading failure. So it took down their EBS, which is their SAN solution, which took down RDS, which is their hosted database solution, and a whole bunch of network services, dead in the water. So Netflix posted a post-mortem. They figured out what they should do in these types of events and how they would compensate for future failures. So they decided to stay, and they figured out what they needed to do. So I'm going to skip a few outages for brevity's sake, otherwise we're going to be here all afternoon, but I'm going to skip forward to two more recent ones. In June 14th of last year, they had another big outage. Same symptoms as the one in 2011, but different root cause, same problems. SAN failed, EBS and RDS unavailable. You can't get at your data. To make matters worse, when the SAN came back up, not all volumes were clean. So you could reach your partition again, but the data was corrupt. Now, Netflix was again affected at a smaller scale, and again, figured out how to work around it. And then the big one hit, a thunderstorm. Nothing that Amazon could really have done to prevent the thunderstorm on the East Coast. All the load balancers had a really significant latency spike. Their API went down. You couldn't launch anything new. You couldn't change any configurations. East Coast was unavailable. And if you can't redirect your traffic at this point, you're down. You have to get out of the East Coast. So kind of look like this. Quora, Reddit, Netflix, Pinterest, Instagram, they were all off the internet. You couldn't reach them. Now what I learned from this, I'm not sure if you can all tell this, what's the one thing that all these logos have in common? That's right, they have red in their logo. So that's actually the real key. If you take anything away, just take the red out of your logo, you'll be fine. But we weathered most of these outages, and we didn't lose a significant amount of data either. We had some degraded API calls, some higher latency, but we were up, at least within operational tolerances. And we learned that the rules, they really have changed. You took things for granted in the data center, and you can't anymore. The strength and the weaknesses of your platform are different. Your architecture has to change as a result. And there are some new truths you're going to have to live with. Number one, your network will partition all the damn time. If you expect your network to be up, you will be very, very disappointed. We've seen it for as little as 20 seconds and for as long as 24 hours. Disk I/O, out the window. It's a multi-tenant situation you're in. You're on this box with 2, 5, 10, 20 other people. You're sharing that I/O channel to the local disk. If Netflix is on that same machine as you, transcoding video, your I/O is out the window. And noisy neighbors is a real concern, because who knows who comes up there? That could be a MapReduce node right there. Your IP addresses will change, something that in most data centers you would never have happen. But the TTL on the IP address you're given from Amazon is only 8 hours. After 8 hours, you could have a new external IP address. The DNS entry is only 60 seconds. So every 60 seconds, something that connects to your host name has to re-resolve. Now your DNS is on the critical path too. And there are systems that rely on IP addresses rather than host names. Varnish backends will only resolve on startup time. So when that IP address changes, your backend's gone. And Cassandra replication needs it as well. I feel myself breathing into the microphone. It must be not very pleasant for everyone here. Is this still good in the back? Can you hear me like this? If I breathe too? Fantastic. All right, so instances will die. And it's always the worst case scenario, right? It's always going to be the database master. And whether it's a hardware failure, a bug in the host, or you accidentally killing the wrong node, an instance is going to die. and it might have actually been one of my colleagues at Canonical, when we did kernel development for AWS, we didn't have a sandbox environment to do it in. So we would upload a kernel to their production environment and test it out. And sometimes we take down the host. You know, Zen has bugs too. But even more importantly, humans make mistakes. It could be a hardware failure. It could be poor design, but more likely there's humans involved. It could be humans from Amazon, it could be your humans, it could be you. And the best thing you can do is prepare to mitigate that failure. So embrace it. Hardware will fail, humans will make mistakes, there will be thunderstorms. Or I think maybe this is a better slide for here. So what can you do? Don't bring a knife to a gunfight. What worked in the data center won't work in the cloud. We talked about that. You have new constraints, but there's also new tactics you can use that will work a hell of a lot better than they did before. Let's get into the nitty-gritty. Data stores. You have a choice. I think there's been a bunch of presentations here on Mongo, on Cassandra, on React, and so on. But they all have their pros and they all have their cons. Is there anybody not familiar with the CAP theorem? Okay. As the previous speaker said, thank you for speaking up and being brave, admitting that you don't know the CAP theorem. It's like cheap, fast, good, pick any two, except in this case, pick any one. Your choice is consistency, availability, and partition tolerance. Now, because your network can go away at any time, you don't have a choice when it comes to partition tolerance. You have to. So, do you want to be consistent, or do you want to be available? That's essentially what the choice boils down to. So, if you have to sacrifice one or the other, my first advice would be, if you're in the stock trading business or in the hard monitoring business, maybe availability, because consistency is super important. I might want to have the right price or the right heartbeat before I make a choice. But in all other cases, probably pick availability and go with eventual consistency. So on the left, you see a few that fall in that category. CouchDB and any Dynamo-based system goes for eventual consistency. On the right is your traditional database system like MySQL, Oracle, and anything that's big table-based like HBase, and your standard master-slave systems. So let's take a look. Amazon offers RDS. Does anybody not know RDS? RDS is the hosted database system that Amazon provides for you. It's like a hosted MySQL or a hosted Oracle. They don't offer Postgres, unfortunately, but it definitely beats your own MySQL or Oracle instance inside of Amazon. And the reason is they actually have access to the hardware, they can set up the replication, they can set up the failover. So if you would run it yourself, you have their issues to deal with, their chances of killing a node and so on, plus your own replication setup. But the downside is you can't replicate out of it. So once you're in RDS, you can't get your data out of RDS replicated. So you can't have them host the master and a bunch of slaves, and you do a read replica somewhere else. It's also a 7-minute failover time every time for us. So when we have a master go down, before the hot standby comes up, 7 minutes pass. That might be okay for you, it might not. We've architected around it. 7 minutes is okay. Amazon, at the end of last year, introduced Redshift. The idea is that you can still treat it like an SQL database, but it's not very good for real-time stuff, but it's fantastic for analytics. So to make RDS more useful, put your OLTP stuff in RDS, and put all your analytics stuff in Redshift. That way you're not pummeling your operational database when you're trying to run the reports weekly or nightly, and you can still serve your traffic as goes. Now, it's priced very competitively. If you look at most BI solutions, Redshift is way cheaper than what you would find out there. But it's on you to make sure that data stays consistent, and that thing that you have in your live database gets transferred to Redshift, because again, Excuse me. Again, you don't want to do your live queries against it. It's simply not fast enough. So moving away from the SQL world, you can go to big table-based stuff. The white paper from Google is quite famous for it. HBase came out of that. Google App Engine uses Google's own big table. There is Accumulo and Hypertable, which are two other open source implementations. The first one, Accumulo, is an implementation from NSA, which is basically based on security features on top of HBase. And Hypertable is yet another design. HBase is the one that has all the traction behind it. But it has the same problem with network partitioning. HBase forces you to deal with a write failure when it happens. Or in other words, if you tell HBase, I want 3 copies of that data, and you give it to one server, it'll try to replicate to 2 and 3, and if it can't, it says, sorry, couldn't, your problem, deal with it. So if you have a network partition and these other servers can't be reached, if there are timeouts, you're stacking this on top of your user. You might go back and try a different cluster, but now these times are serial. You just took 2, 3, 4, 500 milliseconds to try the write, you failed, another 500, another 500. But that said, HBase is definitely the most mature and the most widely used one. The region server is recoverable, but leads to some downtime. The region server is basically the index of which shards it should be talking to. And it used to have a single point of failure on the name node as well. That's now fixed. So very recent releases of Cloudera, or if you are brave enough to run the unsupported Facebook patch set on top of HBase, will have that fix in it. There aren't too many people that run HBase in production in EC2 yet. I think it's still better suited for real hardware, real networks. But if you're willing to give that a go, there's a company called Cloudera that releases something called CDH, which is a Cloudera Hadoop distribution. And CDH4 has the properly patched version of HBase in it. So, given the fact that we can't really recommend the last two, the ones that are left are the Dynamo-based stores. Cassandra, React, DynamoDB, any of those names new to anyone here? Just raise your hand. Excellent, you all know. So, DynamoDB is hosted by AWS. It's just like RDS. It's a nicely hosted service. It is really fast. It is really performant. It is reliable. It's fantastic. I can't speak of it highly enough. But its price tag is different. So unlike RDS, which is based on instance time, how long is your database server up, Dynamo charges you based on IOPS. How many reads are you doing? How many writes are you doing? How big is that data? Does it have to be consistent? I did a quick calculator for 5,000 reads and 1,000 writes on 2 terabytes of data. And that used to be $6,000 a month. They just dropped it down to 4 because they optimized their prices. But it's pretty obvious that if you have high rates of reads and writes, DynamoDB very quickly becomes economically prohibitive. And if you think, excuse me, and if you think that you can buy an SSD of that size for about $800, there's just no comparison. So React and Cassandra are really good options to consider. We personally run Cassandra. Basho, which is one of the sponsors here, offers React Enterprise a really good price for startups. So if you're just starting out, they have a really nice price package for you to get started. And DataStax is the company that offers the enterprise version of Cassandra. And I very much recommend getting that if you're going down that path. So both React and Cassandra have really successful implementations inside of EC2. They're probably the best suited for your scalable store in AWS. And for Cassandra specifically, Netflix has done quite a few tests and has a lot of white papers out there on how it performs. So go check that out. And I saw on the schedule, I think there's a talk on React by Basho tomorrow. So they'll probably go in depth on that kind of stuff. So the other option is to go hosted. You could, instead of trying to run your own data store inside of AWS or deal with the expensive pricing of Amazon, go to a provider like that. Most of them, CouchDB, Mongo, React, Cassandra, HBase, they all have a hosted solution you could go with. Most of these technologies are quite new. I've played around with some of them. Expect to be a guinea pig, basically. Some of them are not out of beta yet. And even if they are, again, the technologies that they're trying to manage for you are quite new. I think their biggest problem would be the comfort level you have with trusting a third-party provider with your data storage. You're now reliant on their uptime, their availability, their bugs, and so on. Most of them do quite well on their first level, but specifically on failover is where corners are being cut. So be very mindful when you try that out. So these are all links to to hosting providers. The ones from MongoDB is one per letter, because there are that many Mongo providers, but for most of the others, there's only one commercial company. So be sure to click on all the letters individually. There's another thing you can do, though. Client-side storage. Who's familiar with the concept of client-side storage? Excellent. So most people will have some sort of service that works on the web and probably is going to be visited by a browser or mobile app. In that case, you have access to about 5 megabytes of storage on the device. So rather than regenerating the data on your server, or keeping all the data on your server at all times, or regenerating it per request, you can do incrementals, or use it as a reasonable fallback for when your servers aren't reachable. So imagine this implementation. As a JavaScript client, I connect for the new data. The server is down. The cache server in front gives me an empty response. If I have the previous result in local cache, I can probably come up with a pretty good response despite the fact that the remote server is down. It's one of the ways that you can get around outages like that. Sorry, I'm trying not to breathe out too much in the mic. Amazon gives you 2 options for a local disk if you're on your instance. You have Instant Store and EBS. Instant Store is a machine that is connected to your local AI drive on the local box you're on. EBS is the SAN. You're going to go over the network and use a SAN storage device. Instant Store is almost always faster. I say almost always because you have to deal with noisy neighbors. So if you want performance, go with an Instant Store, get multiple of them, and you can even stripe them together. They'll be reasonably fast. But the problem is that the I/O can fluctuate by a lot. So if you have upper or lower bounds that you really need, you have basically 2 options. One, go with EBS. The baseline is guaranteed, but the network can partition. EBS also has a provisioned IOPS option where you can go up to 2,000 IOPS per second. Well, IOPS. And although it works, it's ridiculously expensive. Again, if you compare it to the cost of an SSD, it's not worth the investment. So we run with most of our machines as Instant Store. First of all, they're throwaway, as they should be. And usually they're fast enough. But for the ones where we have to have dedicated throughput, we use a RAMFS. Because nothing writes faster than a bit of RAM. And usually you can spare about 1 gigabyte for your hot writes, which you then swap out onto disk when you're compressing them. All right, and if you don't have throwaway data, consider an EBS RAID 10, because the individual EBS volumes can still fail even though they're on a SAN. So even though they store multiple copies of your data, the volume itself can become corrupted, which is why you want the RAID 10. Now to the absolute, what I consider, best feature that I've seen on the internet in a long time, and definitely Amazon's best feature, is S3. It's their HTTP-based storage system, and it has one critical plus for it. It's up. It is always up. The amount of 9s that they managed to achieve is ridiculous. So even though the latency is going to be high, you can count on it being there. It might sometimes respond within 500 milliseconds, 1,000, 1,500 on the high, but it will be there. It's the most durable, most available data store that you have. So if you care about your logs, push them there with log rotate. Compress them beforehand and save about 80% of your bill. If you're okay with reduced redundancy, you can save even half on that. We did an experiment putting an S3 fuse on top of that and just see if we could treat it like a local file system. But the latency is so high that that is simply not possible. Now, on the good side, every language I've ever used has bindings for it. So interoperating with S3 should be really, really easy. Okay. So we talked about not having control of the network. but you can control what traffic is flowing to your network. And that lets you define all kinds of mitigation strategy, like serving from a local cache, serve stale, you could degrade, or you could even reroute. So first things first, best advice I can give you is stay local if you can. Once that request hits your machine and you have to go off box, you're once again exposed to the potential network partition. So you might not get that answer, or you might get that answer slowly. So if you have a strong, how do I best say that? If you have a data set that's not very large, you might consider replicating that to the local machine and serving stale from there. So run your MySQL slave on one of your local machines. Because who cares if it's 30 seconds out of date because of that network partition? I can still give you an answer, which is superior than no answer. If you do have to go off the box, try to do it async. You can also write your logs after you serve your request to save another bit of latency there. If you want, and I think you should, you can do scatter-gather. Ask multiple machines for the answer and set aggressive timeouts. Otherwise, you'd be doing it sequentially. I'll ask you, and I'll give you 200 millisecond timeout. You might not give me the answer. Another 200 milliseconds. Another 200 milliseconds. If you do scatter-gather, I'm probably going to get a answer within 200 milliseconds. If you go outside of your EC2 zone, and I think everybody knows this, your risk increases. They've done a lot of logical partitioning of their network. So if you're in your US East 1A and you make a connection to another US East 1A, you're much more likely to get that quickly and reliable than when you go outside of your zone. Think about that when you set up your storage systems, but also think about that when you partner with other vendors. They might not be in every zone. You might always have to cross that boundary. Right, cache what you can. Anybody here not using Squid or Varnish? Interesting. So we have highly changing data. In fact, as you're browsing the web, with every click you do, we're probably updating that data. But if you store that data with a low TTL, but a high grace, and grace means if you can't get an updated copy from the backend to serve what you had before, you can mask almost any backend outage. So think of an article that might update frequently, or comments on an article that might update frequently. Set the TTL to 5 seconds, set the grace to a minute. That gives you 55 seconds for network connection to recover before users would start noticing. Redis and Memcache, I'm assuming, are pretty known entities. You can use those for SQL type caching as well. By the way, this bag is a photo that a guy called Matt Inman took, or he's known as a comic as the Oatmeal. And he got sued for doing something that he believed in very strongly, and rather than paying people off, he ended up with that bag of cash. It's cut off at the bottom, unfortunately, but go read the article. It is the best thing I've read on the internet in a long time. All right, elastic load balancers. If you're on Amazon, you should be using ELBs. If you're not, you're increasing your risk for failure. They're incredibly economical. We put more than 30 terabytes of data a month through one of them for a cost of less than $400 a month. This is not going to be the high order bit. Start using them. They auto-scale for you, and they rebalance as they're needed. And it definitely beats running an HA proxy instance yourself. Because once that traffic hits your HA proxy instance, it is responsible. That one goes away, your traffic is dead. So ELBs are a combination of DNS-based load balancing as well as appliance-based load balancing. It's basically two things in one. And the way it works is that Amazon announces an IP address when it's being looked up, and you're being routed to one of the active zones. It's one of the reasons that their TTLs are so short on DNS entries. And once you hit that zone, you're going to hit one or more appliances that are sharing IP addresses, which will grow and shrink with the amount of traffic you get. Now, on that note, ELBs do take a little time to warm up. Their algorithm is very basic. It says you have traffic. If you're getting close to the maximum amount of traffic, I'm going to double the capacity. Once you get close to that, I'm going to double the capacity. So if your traffic increases or drops faster than their algorithm, and this is many, many minutes, talk to their support and have them pre-warm your ELBs. If you know that you're going to do doing a big launch, or maybe your app gets used every morning at 9 o'clock exactly, you're going to get what looks like outages to people just because their ELBs take a time to warm up. The downside with ELBs is that they only work in the region they're in. So they only work in US East, they only work in US West. There's no way to get that traffic out of that zone if you wanted to. And that's where global load balancing comes in. You should be in more than one region for your website. The few outages I talked about before, they were all in US East 1, but there's been outages in other zones as well. If you can't move your data out of a region, you're susceptible to downtime. There's just nothing you can do about it. But also if you have users that are in multiple regions themselves, like in our case, Europe and the US are our biggest markets, that gives us 3 data centers to be in. And even in the worst case scenario, we can have an active serving pool, and you're just paying in latency. So if you were supposed to go to the West Coast because you live in San Francisco, I can always send you to the East Coast. I'm paying 300 milliseconds extra round trip. It's going to be a bit slower, but I have an answer, which still beats 503, sorry, you can't read the news. You can pick your TTL for failover. We pick 15 minutes, and your entire region can fail over to another data center. So you should be able to configure your DNS provider to monitor the endpoints that you have and say, if you can't resolve them, if you can't make HTTP connection, if you can't get there, switch it over to another region. And you can do that rule-based too. Maybe you don't want to send all your European traffic to US East. Maybe that would completely overload it. But you can set up rules that say, a third goes to one data center, a third to another, a third to another. Sure, the latency goes up, but the alternative is much, much worse. If you are a US-focused company, and you may not be while you're here, the data centers you want to be in are US East 1 and US West 2. US East 1 because you will serve your European traffic well enough and the prices are good. US West 2 because it is their newest data centers with prices that are comparative to US East 1, but the hardware is better. In fact, we see that even though Amazon has normalized all of their instances to compute units and RAM units and so on and so forth, that our response times on hot cycles in US West 2 are about 15 to 30% better because you have access to better L2 caches, better buses, and so on. Sorry for the geeking out there for a moment. So another reason to use weighted global DNS rules are that you can also roll out new versions of code that way. You can pick a chunk of your data center, upgrade it, put it in a different ELB, and give it 1/1000th of the traffic, and see how it does, and ramp it up slowly. And even if you have to upgrade an entire data center for whatever reason, you can offload all that traffic and switch it back when you're done. So I don't do shout-outs very often, but I think Dyn deserves one. There are DNS providers that are absolutely fantastic. If you run DNS at high scale and high traffic, go with Dyn. I see a few heftily nodding faces in the audience. I cannot recommend them highly enough, and if it weren't for them, we would have definitely been bitten by the last outage. All right. Anybody not using a CDN? Are you not using it for a good reason? Good, excellent. So everybody's on a CDN, so you know that cacheability really improves your performance. A very simple and easy trick you can do is if you have dynamic pages that look like they can't be cached, look if you can do that dynamism in JavaScript instead, based off an async AJAX call, which means just fill in the you're logged in as Bob, get that information Bob from somewhere else, so you don't have to cache the entire page as a user or avoid the caching. We set some of our cache rules with a very, very low TTL, but again with a very, very high grace, meaning that we ask our CDN provider to refetch often, but if they cannot, keep serving the stale copy for a very, very long time. You might be wondering why there are no more new comments on the article, but you're still reading the article. Amazon offers CloudFront. I think it's a okay product to start with. If you're growing up and you have bigger needs than that, go check out a company called Fastly, who have a CDN based on Varnish. Very competitive prices and very good quality. Okay, I see at least one user in the audience. All right, on to some other parts. I talked about failures and what you can do and which parts you can use well and which ones you shouldn't. But really, a big part of mitigation is prevention. You don't want to be fighting fires. You want to know that fires are coming. So knowing how your infrastructure and application behave at all time is key. So if you can improve your time to detect, improve your time to respond by spotting potential issues earlier, you can avoid that firefighting. We capture about 200,000 metrics a second, which is similar to what a company called Etsy does as well, who are arguably trendsetters when it comes to graphing and monitoring. Do these components look familiar to people? Stats.D, Graphite, Collect.D? If you don't know any of them, or don't know one of them, just raise your hand. Okay, one's going into. So Graphite is a system where you can send metrics to that will graph them nicely for you, and you can do all kinds of fancy math. Collect.D is a way to monitor your system on the local host, and you can say things like, is my HTTP server up? Is it responding with 200s? Is this process running? Is the CPU usage too high? And Stats.D is a way to aggregate stats and send them off to Graphite. So you would run Stats.D and Collect.D on your local host, and they would be sending information off to Graphite for graphing and analytics. So there aren't actually any logos for any of these. Collect.D doesn't have a logo, Stats.D or Graphite, so I use beignets because they're tasty. So first one's first. What should you be graphing? Graph events. Those vertical lines are deployments. Nothing quite tells you, and nothing quite helps you figure out what's wrong with the system if you can see when somebody made a change. So if you see your latency spike at some point, which you can see right here, you can be pretty sure that something happened within this deployment, because that is not a usual spike. So if you know what was deployed and by when, it really drastically lowers your time to detect and time to response. Start comparing. All numbers are relative. So even if you have a nice flat line or one of those nice waves that you expect, is it going up or down? And is that good or bad? So compare it week to week and see the percentage change as well, which is that white line on the right that shows that they're only doing 80% of what they were doing before. Or to explain the whole graph, these are AMQP requests per second over the last 2 weeks and the 2 weeks before. So you can see one line that says, what's it like now, which is the green one, and then the blue line, what was it before? And you can see that their requests are going down. That might be a good thing or a bad thing, but at least you know it's different. Who's familiar with Holt Winters? One Lone Ranger. Holt Winters is a way to know what your normal is. Because what is normal changes all the time. Your website gets more popular. You have more articles, more edits, more readers, or less of them, and maybe that's okay too. So Holt Winters does something called confidence bands, or you can calculate confidence bands with them. And they say, given all the data I've seen so far, I predict the data to look like this. And in this case, the yellow line is the prediction, and those two dotted lines are the variances that are expected. So you can see here, for example, historically there's been a lot of variance in this time. Sometimes it might have been really low or really high, so this was probably very spiky in the past. But in this time frame, it's been pretty predictable. And then you have the green line that shows you your current traffic. So you can learn if your normal is changing. And again, that might be good or bad, but at least you know. The next thing you should do is try to find individual outliers. Yeah, it's always fun to find a black sheep. I had a Where's Waldo picture before, but people were just trying to find Waldo and not listening anymore. Absolute numbers mean very, very little. For example, let's say that your average response time is 100 milliseconds for your web servers. And you have your threshold set to a second. How are your servers actually responding? When we say average is 100, Do we have lots of them that respond in 10 milliseconds and one that's at 990? Is that one close to failing or not? Average doesn't tell you very much. But if you use the mean and standard deviation, it'll tell you a lot. For example, if you have 100 milliseconds response time on average, and your standard deviation is 50 milliseconds, 0.03 of your machines should be responding at 250 milliseconds. That's normal. That's the bell curve. So if you have one in there that's outside of the normal, that's not good. There's a problem there, even if it didn't go over your absolute threshold of a second. Don't alert on absolute numbers, alert on trends. In this case, the normal is slowly changing. If you looked at a small time frame, like maybe this, you wouldn't notice. Let's say that's a week or a month. But if you look at the whole view, you see your normal is changing. And it probably means that your architecture should be changing too, or at least your capacity. Maybe it's your disk that's filling up faster than before. Or maybe the machine is responding slower and slower and slower. Or maybe these are the number of nodes that you have that are misbehaving. And slowly your performance is degrading. The other nice thing about graphite, these are all graphite graphs, by the way. The other nice thing about graphite is this is the graph it paints, but it can also give you the same data as JSON. So maybe you don't want to graph, maybe you want to send it to a decision engine like Riemann, or maybe you have custom reports you want to run on it. The data's there. I'm sure a lot of you already have systems in place that may not have monitoring or graphing in them yet. It's not necessarily hard to retrofit it. This is a trick that we use inside of our Apaches. So we have a very, very simple static thing that we serve. It doesn't do anything, but we want to know how fast it is. So we define a custom log format, and the top line is what you send to statsd. That is literally the thing that it expects over the port. And the %d is the response time in milliseconds. So we do a custom log, we pipe it to localhost over UDP to statsd. Apache fills in the response time. Instant stats. We can see what endpoint is being hit and how long they take and how many we get, all real time. We do this for response codes as well. So we can easily see what the 200s are, the 304s, the 500s, the 404s, free graphs. And for varnish, we did the same thing. I wrote a vmod to send stats directly to statsd. The blog post is there, so you can link on that once the slides are up. Second shout out. Anybody used New Relic before? Like it, love it, hate it? If you have a Java app or Python, Ruby.NET, or whatever you're writing, odds are that they can do in-depth profiling for your app. They're one of several providers. We use New Relic and we really like them. But if you already have a running app, consider a third-party profiling tool. It will uncover so much stuff for you, and it will definitely save your ass when it comes to improving latency. I was doing so good with not swearing too. All right, configuration management. I'm going to go through this one pretty quickly because I've seen several talks on it at this conference. But just like you want your application to be deployable everywhere in a consistent state, so do you want your configuration management to take care of your servers. So the holy war is Puppet versus Chef. What's the holy war in Java world? Java versus Clojure, is that one? Emacs versus IntelliJ? Help me out here. Imagine I just said that to the operations people. The real answer is just yes, use one. If you're not using configuration management for your system, you don't know what state it's in, who knows why it's slow, who knows why it's broken. So infrastructure as code, it's a big deal. We partition our environment into dev, staging, canary, and production. Canary is a node that's actually serving production traffic, but it's only one of them. So we have our internal QA, we push it out to one host, and if that one doesn't go up in flames, or given the forecasting isn't performing any different than we thought it would, we upgrade production. We build our own together with Ubuntu, Cloud.Init, and Bodo. Bodo is the AWS library for Python. And it configures our instances to talk to the right puppet master and configure themselves. And we get our new machines up in about 15 minutes. So if we need more capacity, from realizing that we need it to operationalized is 15 minutes. AWS recently came out with AWS OpsWorks, which is a hosted version of Chef, which is the other big configuration management system out there. And they did it free of charge, which is really cool. So if you're new to configuration management or really don't want to host your own, go take a look at OpsWorks. It has some limitations, like you can only use Ubuntu 12.04 or Amazon AMIs with it. But it's a pretty damn good start. And it supports deploying your app from Git or Subversion, or even HTTP and S3. It's pretty flexible. It's just been released, so it may have some teething problems. Yeah, go take a look. Earlier over lunch, there was a talk about Vagrant. Did anybody go to that one? Not too many. OK. Vagrant is a nice way to set up your local dev environment using a VM that's pretty much identical to production servers. We use a very small if statement on the top of our Puppet manifest to polish away the difference between EC2 hosts and local hosts. Things like, where should my stuff be sent? Where does the package mirror live? The other way to get faster deployments is to roll your own AMIs. Both Puppet and Chef provide ways to compile the catalog and then build an AMI out of it. There's an AWS Java library as well that's exceedingly good at it. And the previous speaker was mentioning one for Clojure. Do you remember which one that was? Pellet? I think it was called Pellet. Anyway, you have your choices there. But having your AMI pre-baked with your application drastically, of course, lowers your time to respond. If you just have to hit a button and there's 5 new servers there, that can help you greatly. So confident deploys. No matter how resilient your architecture is, your deploys still have to be reliable for that to matter. So deployments are by design a fundamental change in your infrastructure. So a lot of ops people have fear when you start changing things. You might break things. So the best thing you can do is try to take the fear out of that change. Ideally, deployments should be easy and they should be often. And if you can avoid making any unnecessary mistakes in the process, the scariness just goes away. So to highlight yet another talk that's being given at this conference, I think tomorrow, on continuous integration. What we do is we push our code to GitHub. We have Jenkins, which is formerly known as Hudson, I think, in the Java community. Automatically run all our tests, and if they pass, automatically build a package out of it using FPM, and then it pushes it to our apt repository in S3. So from commit to deployable in one command. We split our apt repository to dev, stage, canary, and production. So if the host is in canary, it only pulls from canary. And we just promote the packages as we see fit. This one's ready to go to stage. This one's ready to go to canary. This one's ready to go to production. FPM is the bare minimum that you need to make a bunch of software packageable. I know for Java you can use a jar, but the nice thing about still doing FPM is that it allows you to bundle the configuration files and many directory structures and so on that you want as well. Plus it automatically gives you versioning, so it might still be worth it too. Deployments shouldn't be exciting. When you can build releases with one button, the next step should be that you can deploy them with one button. We use a very simple parallel SSH plus apt-get script. That's all we need. At the end of that, if it went well, it sends one of those deploy lines to Graphite. So it tells us it was deployed. We have 5 screens up in our engineering environment that show us all the key metrics. Not because we use them for monitoring, but we know what the normal is. When our salespeople come in or support people come in, they can see what the normal is. For your non-tech processes, you might want to consider just something simple as an automated checklist, just to make sure that every little bit has been ticked off. And there's a little website called Checkmarkable, which is a pretty good resource for that. All right. The last 2 things. We find that really production traffic is what will tell you how your application is behaving. You can test all you want. You can be reasonably sure that you didn't introduce any bad bugs. But do you know that it performs? Do you know that it's fast enough? Do you know that it still behaves like the previous one did, or at least the bits that you expect to be the same? And there's 2 techniques that you can use to take the sting out of those deployments. One is called dark launches. And the idea is that if you have it works particularly well if you have a visual website, to still call the new feature, but render it in a hidden div. So who knows how long it takes, but it doesn't matter because you called it async. Who knows if the presentation went well, but it doesn't matter because you put it in a hidden div. And then report back on the results from the web page on a subset of your page views. So you're effectively exercising the whole code base, just the users don't see it. You know, that new widget that you wanted to add, or that new button that you wanted to try out. So you can get a performance and an error profile before you potentially break the site. A/B testing is obviously after that. Yahoo released a project called boomerang.js, which exactly does this type of stuff. So it allows you to go back and forth on the metrics. And then there's a hosted service like Kiss Metrics that can do it for you if you want to do it like that. And then the last one is a technique called shadow traffic. Who doesn't know what shadow traffic is? Cool. So normally, you have traffic. It goes to your application. The application responds. Done. With shadow traffic, your traffic goes to an application and a shadow application. Once the response from the application comes in, it goes back to the user. When the response from the shadow application comes in, there's a comparison made. How long did the first one take to respond? How long did the second one take? Did the first one give it 200? Did the second one give it 200? Those deltas are compared and then sent off to your stats or error reporting. It's very complementary to dark launches. It is very easy to do it with a single IP tables rule where you say 1 in every 80 requests goes to our shadow proxy app. And I linked a very basic Ruby one from this slide that lets you to send 2 requests off. This one easily scales to about 150 requests a second, so it should be pretty good for testing. All right, I noticed I was going a little bit slow, so I picked up the pace a bit. That was the last one. Thank you very much. Time for questions. No questions? Yes? So the question is, Puppet versus Chefs, should we run a master or should we run a headless version? They both work. The master version is a little bit harder to scale, but it's very well documented and done many times. The downside of running a client-only version is that all the code must go to the client. So if your individual client is compromised or isn't configured the way you